All right, the next piece of the 6A's rubric that we want to talk about is academic rigor. The first part to this is with respect to how we developed our driving question. So what we do with all of our projects, including this one, is we take a look at all of our standards, myself for pre-calculus and then Coach Steve for physics. We try to figure out which of them kind of match really well, and then we create projects around that kind of match. In this case, we use the standards over quadratics and conic sections for math and the physics concepts of 2D kinematics in order to create this project on catapults. In order for the students though to develop their driving question, we first had to give them an entry document that was kind of an old-fashioned piece of paper, a letter, which kind of described the situation from medieval times with the king to his subjects in order for them to attack a castle called Bomberg Castle. In addition, the students had to figure out kind of their need-to-knows with respect to content and logistics. From those content need-to-knows, we had just a brief class discussion around what quadratics are, a reminder of them, what 2D kinematics are based upon their knowledge of the already existing knowledge of 1D kinematics, and then from that they were able to create their own driving questions, and after they created their driving questions from each group, we as a class chose the best driving question for this project, which ended up being how can we use PCAP, which is pre-calculus aligned physics, and other Greek concepts to construct the best catapult and destroy the Bomberg Castle. The idea around the best catapult is for the physics projectile motion. The idea around the Greek concepts is this idea that conic sections were actually created by the Greeks, so they had to try to connect the two together in order to solve the problem.
It's important to note that the entry document was historically accurate as well. We included Newton in there. It was during his time period when this castle stood, and we even included the king that was actually reigning during that time period. During this project, students had to do a lab to find the initial velocity of their catapult. So they built their catapult, they tested it, they tweaked it, they made it better, they put it where they wanted to, and then they actually had to find the initial velocity. If they didn't do it correctly, that means that the rest of the projectile motion stuff that they do was wrong, and that means they'll never hit the target. So it was a really big cause and effect situation where they really had to focus on taking the right data, making sure everything was accurate, making sure it was right before moving on to the next steps. So it was a really cool project in the fact that they really could see if they did something wrong or right off the beginning just because of how they did their calculations.
And the really cool thing about the academic rigor with respect to the combination of math and science is that the students needed to understand the projectile motion and the fact that it was a parabolic path in order to then do the mathematical modeling. So not only did they have to find the mathematical models in 3 separate ways using vertex form, standard form, and conic form, they also had to understand and prove to us, demonstrate to us, why each one was beneficial and how each one could be necessary to tell something different about the projected pathway of the catapult hitting a man or a place on the castle.
And the physics, they had to understand initial velocity, acceleration, that gravity plays into the whole calculations, and they really had to understand all the different ways to solve kinematics.